Very good evening to all of you. Today I'm going to discuss and give you some example about the applications of geospatial analysis, preferably into our discussion about whatever data that available in our country. So the first of all, we go to the Facebook. So one of the site that's very important in our discussion today is actually we are looking into this CPRC. So CPRC is actually National Crisis Preparedness and Response Center. It's located in our Ministry of Health under the kawalan penyakit, or we call it as disease control. Okay, so what I'm going to explain and give some idea is actually we are going into this, okay, the 19 November post around 7 a.m. in the morning. So I'm interested to look into this particular data, and based on this particular data I'm going to download it and then put in my mapping, and after that we are going to run for the analysis. So it's depend on your computer connection. All right, so basically I already download this particular sample of data, so perhaps I can show you to speed up the process. So this is the data that I already download from the CPRC. Okay, it's actually talking about the case that already occurred in Malaysia for the epidemiology week 46 in this particular year, which is dated until 10 to 16 November. So actually I'm waiting for the latest one. Preferably maybe next week we'll be posting something in our website, and then we can start run it again, no problem. Okay, so what this table is talking to you is actually a very descriptive manner, looking into the states and then looking into the cases, looking into the comparisons between week before and the week 45 and with week 46. But actually now we are in the week I think we are in the week 47 to 48, and then this is about the cumulative case, and then it's from 2019, and then this is the similar comparison for similar week but different year. Okay, so based on this particular data, I already construct a tabulation based on the spatial recognition using the QGIS, because the QGIS is freeware. So I got the Peninsula State Malaysia map, and after that I already include all of this data set into my computer, and then I already run it for the purpose of analysis. All right, so this is Peninsula Malaysia. So I got this particular digital map. So if you can see here, we got I'm going to explain only for the Peninsula Malaysia. So I'm so sorry to our colleague in Sabah and Sarawak, because um, uh, we are going to analyze this one later on, because we are focusing more on the neighborhood that are close related together within this particular region. Okay, so we go to the Peninsula Malaysia here, and then you can open the attributes, and then based on these particular attributes, actually what I did is we click this edit toggle button, and then we make some editing on our data. So the data perhaps is almost the same based on what being reported in CPRC. For example, in this particular data, we see the Perlis here. They got the previous case, 1, 2, and then the cumulative case for the 2018 is like this. This one is 2019, and then no death is being recorded based on this particular previous year. After I finish this particular update of the variable, so I'm just going to hit the save edit buttons, and then close this particular software. And then we proceed to the new approach using Geoda. Geoda is one of the open source beside the other geospatial analysis, for example, Qgis or any commercial software. This is Malaysia, Peninsular Malaysia, sorry. And then this is the table that we already edit in the QGIS, and then we can see around 12 attributes or locations that are already being plotted in this particular map. So what I need to do now is actually we want to weight it. We want to give the weight of this particular map to a certain sensible weight that correspond to their neighborhood. So I already run it before, but if you want to know more, you can refer to our channel to learn about these steps. Just to give you some ideas based on this queen weight mechanism, we can see there are several neighbors that are being associated with the other group. Okay, I just give you some idea. For example, this is Johor. Instead of Johor, they got some neighbors here, which is we call it as this one is Pahang, and then this one is if I'm not mistaken, is Melaka, Negeri Sembilan, and then this one is Melaka, something like that. Okay, so this is Johor State, for example. They got 3 neighbors, and then this is Penang. They got how many neighbors? This is Terengganu. They got how many neighbors? So this is why we need the weighted first our map before we can proceed with any advanced statistical analysis. Okay, after we finish giving weight to our map, then we can proceed with our spatial analysis. There are 2 kind of analysis that usually being used. The first one we call it as the global morans eye, and then we got the local morans eye. So in this exercise or in this idea, I'm just going to share with you about the differential local morans eye, which is before we proceed with this differential local morans eye, I'm going to use the time editor to teach the computer or this algorithm about my groups here, which is the differences of time between the time 0, which is last week, and then this week, for example. And then I already save it in my geostatistical package data, and then we are going to retrieve it back after this. All right, so to run this differential local morans eye, we need this group so that we can analyze for the significant map and Moran scatter plot. Okay, before I click the OK button, I just want to make some disclaimer so that most of you are not going to think this videos differently. This is just to simulate the idea and give you some insight and overview based on the spatial map and also based on the spatial data, what we can do more in terms of to control the outbreak of dengue that already being occurred in our country. Okay, so based on this particular spatial map and differential local morans eye, we can see there are one particularly significant at point level of 0.05, which is indicate the spatial autocorrelations indications for the outliers, which is we call it as a low high values. So the low high values is actually something that is very low reported here, or the differences occurring here that are low. Something is going on here is low in terms of the difference of 45 and 46, surrounded by all the neighbors that actually not low, which is we call it high. So in this particular example, just to give you some idea, low high indicate that the reading is low, but their neighbors is high. So this is we call the low high, and the high low is actually the extreme value. So this is the example that we want to address. Maybe and perhaps there are something being happening in this particular state that making these particular changes, or these particular areas are considered to be significant a little bit, but the value is actually not very good in terms of the running for permutations analysis to get the significant level based on the pseudo p values also indicate we fail to reject the null hypothesis actually, but it just give you some ideas that we have some area and locations that we might look into a deeper condition, especially on this outlier, why this thing happening. Perhaps we can know better, we can know what kind of interventions, what kind of activities that contribute to this region, for example, in this 45 and 46 epidemiological week. All right, so I think this is kind of long discussion already. I'm just give you some ideas about how you can utilize the secondary data that already being published by our ministry, and then utilize it, and then use some sorts of technology and statistical applications, integrate some kind of geostatistical package, and then you can make some ideas about what we are going to do next in terms of controlling this particular outbreak. Okay, hopefully you find this video enjoy, and please don't forget to subscribe our channel, and please do also look into our series of tutorial in our channel to learn more about the geospatial analysis. With that, thank you very much. See you again next time. Bye bye.